Welcome to Brain Vision.
So in this problem, we have to find out the current through the neutral line. So as you can see in the diagram, this is our neutral line. This is the neutral line. We have to find out the current through this neutral line. So as you can see, the sources, these two sources. Let's suppose this is our VA, this is VB, and this is VC. All these three sources are in the balanced three-phase connection, right? Because the magnitude of the voltage is same. VA, VB, and VC all are same, but the phase difference is 120. So we can see the voltage sources are in the balanced three-phase connection. And if you look at the load, you can look at over here that the impedances are different. So the loads are not in the balanced connection, right? So we have to find out the value of current to this neutral line. So the formula for the current of neutral line, let's suppose this is IN is equal to minus of IA plus IB and IC, and IA, IB, ICs are the line currents through this. Let's suppose this is IA, this is IB, and this is IC. So we have to find out the value of IA, IB, and IC. So let's start the calculation for IA and IB and IC. So as you can see in the circuit, the this 2 ohm resistance and this impedance is in series, right? So if we want to find out the value of IA, so the formula for IA is equal to VA upon total impedance across this line. So the impedance is 2 ohm plus 25 minus 10J. As these are in series, so we can directly add both of them. So now if you calculate the value of this IA, just put the value of VA. So IA will be IA is equal to, the value of VA is 220 angle 0. Just put it over here. This is 220 angle 0 degrees. And if you add both of them, you will get 27 plus, sorry, minus is there. So this will be 27 minus 10J. So let's convert this one in the polar form. You will get 220 angle 0 degrees over 28.79 28.79 angle minus 20.32. So if you further calculate, you will get the final value of IA as, the value of IA is equal to 7.64 angle 20.32 degrees. And if you convert into the rectangular form, you will get it as 7.164 plus 2.65J. So this is the final value of IA. Similarly, we are going to calculate the value of IB as well as IC. So let's calculate IB. So the value of IB will be, IB is equal to VB upon ZB. And the value of VB, as you can see in the circuit, the value of VB is 220 angle minus 120 degrees. This is 220 angle minus 120 degrees. So let's put the value over here. This will be 220 angle minus 120 degrees. And the value of ZB will be this 20 ohm and this 2 ohm, the summation of these two, because both of them in series, so you can directly add it up. So this will give 22 ohms. This will come as 22, and the final value of IB will be 10 angle minus 120 degrees. And if you convert into rectangular forms, you will get the value as minus 5 minus 8.66 J. So this is the final value of IB. Now calculate the value of IC. So the value of IC will be, VC by ZC. So let's put the value of VC. That is, value of VC in the circuit is 220. This is the value of VC, 220 angle 120 degrees. So this will be 220 angle 120 degrees. And if you go for the ZC, the value of ZC is this 2 ohm plus 10 plus 5J, because these are also in the series connection. So the final value of ZC will be 12 plus 5J, and if you convert into the polar form, you will get 220 angle 120 degrees by 13 angle 22.62. And if you further calculate, you will get the value of IC as 16.92 angle 97.38 degrees. And if you convert into the rectangular form, you will get the value as minus 2.17 plus 16.78G. So this is the final value of IC. Now we have to put the values of IA, IB and IC in the formula of IN. So the value of IN, which is a neutral current, which we have to find out, that will be IN is equal to, just put them all the values in the formula. So as the formula of IN is equal to minus of IA plus IB plus IC, and we can write as minus IN is equal to IA plus IB plus IC, and if you put the values, you will get as minus of IN is equal to 7.164, the value of IA 7.164 plus 2.65J, and then value of IB, which is minus 5 minus of 8.66J, and the value of IC is minus 2.17 plus 16.78J. So if you calculate sum it up, you will get the value of IN. Minus IN is equal to minus of 0.01 plus 10.77J, and the value of IN is equal to 0.01 minus of 10.77J. So this is the final answer. The value of IN is the current which is flowing in the neutral line. So that's it for this one.